Okay, so this one here, we've been given the cos ratio. Again, the cos ratio given in exact form implies we have two sides of the right triangle. Okay, so cosine's negative in quadrant 3, so it's going to be down here. So it's going to be -3, -3, and 5 is my radius. Using Pythagoras, I'm going to end up with 25 minus 9 is 16. The square root of 16 is going to give us a side length of 4. Unfortunately, this is positioning. And I need to make sure I locate the right position because 4 is actually up. I need to be going down 4, so that's the right positioning. Once I have my three sides of the triangle, I want to use exact values whenever possible. So I have two sides of the triangle. I try to keep all the ratio parts exact. Okay, so sine theta works out to be -4/5. Tan theta works out to be, that's a positive slope, and it works out to be -4/-3, which is +4/3. And notice that that is a positive slope through there. It doesn't actually ask us to solve for the angle, but let's solve for the angle anyways. Okay, so let's solve for theta, and let's undo that cosine. Okay, so again, be careful. Our input is going to be the ratio. The output is going to be the angle. Okay, so that's how the trig functions on your calculator work. So I'm going to do second cos of -3/5, and it gives us 126. And again, I'm going to call this theta 1 because it's from my calculator. 126.87 degrees. Now I'm looking at my picture. I'm trying to determine if that's the right location. 126.87 degrees is in the wrong quadrant. It's in the wrong location. It's up here. Okay, and this has the same cosine ratio. Okay, this one has a cosine of -3/5. This one, the red position, also has a cosine of -3/5. So our theta 1 position was not the correct answer. It was, what was it again, 126.87. 126.87 degrees. This is a wrong one. This does not match quadrant 1, so I'm going to have to use some symmetry to get the other angle. So I know that's 126 degrees from 0 to the right, so I need to go backwards from 360. So my theta 2 angle is 360 going backwards, theta 1. Okay, that ends up giving us 233.13 degrees, I think. Okay, so that gives us our angle measured in standard position to the point that we are describing. The quadrant with this ratio, the fourth quadrant, quadrant 3. So I need to make sure that my answer is in quadrant 3. So how can we find the other trig ratios given one ratio, z signed? Why do we need the quadrant? So we find the other ratios by solving for the unknown sides. And we try to keep those in exact value. Why do we need to know the quadrant? So we need to know the quadrant. Okay, so we need to know the quadrant because there are two possibilities. Okay, so there's always two possibilities. and we want to choose one if possible. Okay, so we want to narrow it down to one if possible. Okay, now if we can't narrow it to one, we have to give both solutions. If we're being asked to solve for the angle from the ratio, if we don't have any indication of which quadrant we really should be in, we need to make sure that we give both possibilities then.